Okay, so welcome to the walkthrough of how to write the results section. This is a topic that has been a challenge for me to communicate with students because, you as an instructor, you say, well, where's the issue? And the student's job is to just say, help. And, in this case, this was a long time coming, but I think this is, if this video, I think, is going to put you in the best position to develop the thinking skills for the results section and use it as a stepping stone to write a better analysis section and also to produce a more professional quality paper. Now, I wanted to kind of spice things up because this is not, let's say, the most exciting topic to spend some time looking up and learning about. So what I did was I wore a festive, fun shirt to go along with this festive way of learning more about writing lab reports. You all have experience writing reports for in an English paper sense. You have the format that you would have taught in an arts in a language arts class, where you have you have a persuasive essay or an argumentative essay or a narrative or something like that. But in this case, you kind of have to bring those together because you're making a persuasive statement and you're trying to do so in a bit of a narrative way. These are professional journals and they have to tell a story. And that story is science was done and it's compelling. And here's why it's compelling. So there's the persuasive side of it. So as we go into there, just be thinking that this is less about writing an English paper and more employing the skills that you developed in those classes to write a scientific paper. So first, I want to dive in and show you three papers examples that I've seen that just kind of come in, and these are in previous semesters. And just so you quickly see some of their challenges, and then we'll go into the one we want to work with and spend the rest of the time there. The first lab report that you see here, this is next week's lab, or this is week 2 lab 2 for the first semester. And when you look at, and almost all of these are going to be pretty much universally the same. The introduction section and the conclusion section are pretty good, but the results section and the analysis section, the placement of the tables and other minor factors play a major role in making them look sharp, look clean, look professional. So here we have in the introduction section, we're not going to read through it, but you can see the layout is nice. It's clear, it's easy to read. There is a little bit of paragraphing happening in the section that I'm highlighting here on page 1. You want to break that up just a little bit so that it's easier to read in multiple formats, and it helps lend the reader to a sense that these are quick points before we move on to the next one, and not I have to read War and Peace to get through this paper. The first obstacle that you really see here is that this big amount of space on the second page. Just no real reason for it. It's poor formatting. It's lazy formatting. You see that the table is placed here. It's overlaying on the side of the margins there. You can go in there and make adjustments to that. This person elected to present this data horizontally as opposed to vertically. That's perfectly fine, but you got to make sure that it's able to fit and look nice and be easy to read. So something to consider that. You'll also notice that this one, the table has a caption and a label on it, but it is inset with the text. It is not a text box, so it's not easy to move things around to help with better formatting. There is some conversation in here about what's coming, what's the data that's been collected, but it's very sparse. It's very sparsely populated. So this needs some help. Come down here, analysis. Now you have graphs just kind of all over the place, big empty spaces, just opportunities all over the place to do some improved formatting. And this student ended up making those adjustments and coming together and really finishing strong that term. And as you can see, the discussion at the end could use a little bit. It's a little bit anemic, and again, we dealt with that. Okay. Here we have example 2. Now, the first thing that may jump out at you is this big table over here on the right-hand side, and that's exactly what I want your eyes to be caught to. The instructions in the lab manuals are I try to be very clear, and there are times that maybe I miss a mark, but most of the time they're pretty straightforward. They have all the details that you need, and in this one it specifically says only 15 data points, and you can see the student went way beyond that, filling this up with unnecessary information. The main point of this exercise is to become skilled at having a sense of why you might present data certain ways as a table and then as a thing. And we'll get to that one for that particular lab, but I just wanted to let your own eyes be drawn to that. Additionally, over here in the introduction, you see the introduction looks very nice. You read, and if you read through this, you would have a good reference to follow. There may be some italics here that need to be italicized in the text. But the biggest thing that you may notice is that these caption boxes are not aligned. They're not formatted in a way to give them some good clarity. So that's a thing. They're breaking up the procedure into little paragraphs to describe the key steps. But look at this table; it just runs on for a page and a half. It's just a waste of space, and so you want to make sure that you're checking the notes. You want to make sure that you're checking the lab manual rather to know what you need to have in there. And then you can see now suddenly they're shoehorning all these graphs in here without making sure that it's got a logical flow to it. So these are things that you want to take a look at. But the rest of the content appears to be good. This student made these adjustments and did well on this. But opportunities for improvement, formatting is important. Here in example 3, at first glance, this is a very nice paper. You can see that the formatting is nice. The content seems to be well thought out and developed. Here's a couple of things. Maybe you're already starting to see that. Number one, over here, the formulas are not in formula environment. They're just text that's typed in there, which we've had enough practice with the stuff that we've done so far this term that this is a step that you really should not be catching yourself in. You should have those in equation format. And then you got a lot of heavy paragraphing happening in much of the content. It doesn't break the stuff up, make them into sharper focus, 2 to 3 sentence points to get the point across. Your labels and captions, the tables are labeled incorrectly. It's labeled table instead of graph, or figure 1 rather. Data and results, the headers on the one page and all the rest of the contents on the next page. That's a challenge. You have very limited information in the captions that kind of draw some attention and bring up some stuff for the reader to see. It's more than just here it is. What is it? What's important about it? What do you, maybe in your first lab you have 3 different data sets. Well, you want to say data 1 is a triangle, data 2, even though it's in the legend. This is an opportunity to say something about that helps the reader kind of have a sense of reading around the space. Again, heavy paragraphing. The content is great, or at least very good, but the paragraphing slows down reading and really makes it more challenging for the reader to come away and say, okay, I get that. Oh, I get that. Oh, I get that. Okay. So here we have now the lab example that we're going to follow. If you glance at it first, you say, okay, it looks like it's got everything, Dr. T, and it looks rather scientific, but let's point out the flaws real quick before we get into working out the kinks. So the first page is really short. It just has an equation. That is, it does have G in it, but that's all that you get. And in this particular example, they want it to be more about the statistical analysis that you've seen this past week for this particular lab, or at least during lab 1 when you did lab 1. Not sure when you're watching the video. So you want to have more in there, and if we tab down to the bottom page, you see on page 4 there's a bunch of equations. Page 3, page 4, there's a bunch of equations in place there, and the instructions for how to write the short lab report has been fairly consistent for a while, so this student did not take advantage of looking at the instructions for the short lab report. At the time I didn't have the examples that are up now available on D2L or Lab Reference Tools. But nevertheless, again, a missed opportunity to just kind of take a glance at a resource that's been made available. So again, hopefully you're just taking a minute or two every so often and just going there and seeing now as you start getting a sense of the field, what the lay of the land, if you will, in the lab in this class or in whatever lab activity you're with, to know what tools are available for you, because as the semester goes on, some of the early stuff kind of becomes second nature, but there's always a new layer that we're adding to it so that you can continue to develop as a scientific mind and a scientific presenter of your work. So I would start out by coming down here and just taking this stuff, and I'm going to copy, come on down. This writer elected to put all the equations here, so I'm going to just capture this here. X, come on up here, boom, paste. And now your introduction, it's a little bit weighted, but at the same time, these are kind of bulky equations, so there's some give and take. Since there's numerical analysis here, you might even go in there and put in there, say, physics concept as a subtitle, and let's italicize that. And then now you got physics concept and numerical analysis, and these are just subheadings for the given sections. And again, this is procedure, home, italics. Now, I would recommend that you start learning how to use the styles, and you can adjust those styles a certain way. That's a conversation we can have if you're interested. But it would be helpful for your the move towards accessibility for not just students in the academic community, but in society. Would be beneficial if you started looking at using styles. So that's just a sidebar. Again, this is a big old chunk, but look, if you kind of read through there, then the photo gate would turn on its head, follows when the picket fence. So this is a change in steps, so you kind of add a little break in there. It's a little bit easier to read. Maybe it could be broken up one more time, but I don't want to spend too much time in there. So let's get rid of data. We'll just call this results. And introduction covered. And look, the introduction is much cleaner. And if you're really interested in really punching it up, you highlight your text and come up to paragraph. Most everything is preset to left justify, and okay, that's kind of standard. But in a lot of professional publications, you want to use the space to the best of your ability because print is expensive. So, and it lends a little bit more ease to reading if you hit justify to align it with the walls there. I'm not going to do it the whole thing. I'm just going to hit a few spots here. I'll come over here and do procedure just so you can kind of see how it cleans it up. And a lot of times, justify adjusts the space between them in such a way that makes the reading easier, but also makes it sometimes it ends up saving a lot of space. So there's ways to go about doing that. Alright, so here we are in the results section, and look, there's one short paragraph that just says this stuff, and here are two tables. This particular lab group elected to take me up on the offer to do 5, and so we can take a look at their results and you can see how that happened. But look, now in analysis, where's these chart tables are up there and the graphs are way down here. And so there's ways to fix that to make that a little bit better. First things first, let me demonstrate. You see how much space this is taking up? Light run number. Let's turn that from a number and use symbols in a reasonable way. There's a way to overkill it, and then there's ways to, not control, but pound. Right, light run number, and then they have light run number and then run number 1, run 2. You can shorten that to just 1, and then 2, 3, 4, 5. Now I'm not going to fully edit this format in this conversation. What I am going to do is give you a couple of examples and then show you what direction to go, and then what you obviously want to do is pick up the ball and run with it for the remainder of the content that you'd be working with in yours. So if you look right here, now we've simplified this. It reads a little bit cleaner. It's not quite so clunky because it's light run number. It's the light run number, and you might even say, let's say if we take this out here, X, oops, and make this just kind of stylistically consistent. Now we're putting it as for the light one. watch what happens when I shrink this down. I'm no longer using near as much space as I am. Now the graph is filling up, the table is filling up rather the entire margin to margin, but we can fix that. So come over here and grab this, and we drag this over to the side and just squeeze it a little bit until your acceleration has got a nice spacing. And then last but not least, just grab this outer edge and bring that in, and you can see that the table is now taking up maybe half of what it was before. It's a little bit more concise, a little bit cleaner to look at. Maybe we squeeze out a little bit more, get that percent symbol down there. And now, instead of having this big old thing taking up space, you can bring up table 1, and let's go ahead and insert a text box. We're going to insert a text box, just a simple text box. Pops right in there, and if you highlight this, let's move that. You grab the anchor first. Let's grab that anchor and move it up above where we're at, because we're going to be adjusting things. And if you copy that, highlight that whole section that you want and cut it out of there, let's go inside the text box. Remember, if I'm going too fast, I apologize. I don't want this to be a super long video, but I do want to get as much in here as I can. But you can always pause me, right? Wouldn't real life be great if you could pause Dr. T just every once in a while? I'm a little bit much. So let's push play right there, and bingo bango bongo, we can either move this table, we can either put this over here and use the, it can be problematic when you do what you just saw happen, but now you're filling up space that is wasting space, or you can move this down below the table. Come on, move it around. I kind of watch it. It can be a little bit finicky, these tables. So there we go. We'll just put that right there. And now you see the green line popped up to align it, and you just move this out a little bit. And now this table is more concise. If we close off, right click on this, or go into your edit, go up to the top, at the top where you see format, you can do some editing up there. But sometimes the panel is just easier to work with. But if you right click on that, go to the panel and format the shape, and all we want to do is get rid of the line. So we'll click on that, we'll get rid of the border line on there. That's it, done. And so now it's a little bit cleaner. The spacing that's got built into it for the frame of the text box automatically sets it far enough away from neighboring text that it doesn't seem to blend in so easily. One thing you can also do is move this up. But here's a catch. The kind of flow here is that you took data, you use that data to put into a graph. In those graphs you did, you set trend lines from what you got in slopes. And the slopes are what was in this table. So this is out of order of presentation. It's like saying, and then you put it into the oven before you say, now you mix the batter. So let's go down a little bit. Let's grab one of these tables. And what I notice here is we got a light photo gate and a heavy photo gate. And up here I see light is the data table that comes first. So let's go down and grab the light data chart and bring that up. You can drag it. Sometimes that can be a little bit of an issue. Let's see. This appears to be, nope, this is a full table object that's pasted. I keep getting table and chart backwards, so forgive me on that. But I trust that you're following reasonably well here. But you got the light photo gate, so let's just go ahead and cut that out, and we'll go up, and I'm going to go to maybe right above the section up here into procedure, and you'll see why in just a moment. Seems like it's a big mess. Now remember, the first thing that happens whenever you paste a chart in, at least into Word, from Excel into Word, and remember about cross-contaminating between those, it'll oftentimes lead to an image being pasted in, so just kind of tread with care. But the formatting automatically defaults to in line with the text, so the text is this big and the figure is this big, so it's going to make this big gap. So we just change it to text with wrapping, square, and now you see it's immediately started to clean up. And just like we've done before, we're going to shrink it that a little bit. We don't want to shrink it too much, but maybe shrink it to like 3/4 of the space. Because watch what we can do here. If we push this all the way up to the top, and then we want to get one of those text boxes, let's click somewhere else in the space here. We're going to insert another text box, or I'm going to do, you already know how to do it this way. Here's an idea though. We've already formatted this text box. If you change the font size, which some people like to do, it's already formatted. Let's just copy this this text box, come up here, just click somewhere, paste it in there. Wait for it. There it goes. So now it's in place, and what we can do with that is we can move this up to the top and then give it a little bit of a squeeze, and it's going to resize that, and then drag this down until we have the space that we want. Now this doesn't look great right here, but the graph is at the top of the page. There's a caption with it, which we would call figure 1. And we can come down and grab linear plots. Scroll back up here. Linear plots of the 5 runs of the lighter Photogate trial. There's a little bit of maybe syntax question marks here. Notice that they're using Roman numerals for figures. Make sure that you double check this because it is a point loss. Well, I think it's like a half point or something. This should be Arabic numerals. So figure 1 Arabic, figure 2 Arabic, table 1 Roman, table 2 Roman. So that's the idea. Another way to do this, of course, is to just bring this over here. Now we start running into issues here because we're in the middle of procedure and we're trying to format this in the procedure area. So it might be nicer to just kind of drag it down further and get it into the results section. Let's align it with the top of the results section. So as we come down here, it's going to move around, as you can see. And the green line, it's not just going to align it with the margin. It's going to align it with the top of a given paragraph. So let's place this here, and maybe we can shrink it down just a little bit more and see if we can get away with that. It's starting to get a little cluttered in there. You don't want to get too cluttered, but you notice what this particular individual did. They got rid of the captions. I say captions. They got rid of the legend. So let's drag this, cap it right here, move this here. Again, this is formatting. Really, the best thing you want to do is get your content in place and then get your formatting. What I'm doing is getting the content in place in the right order. So now I've done this formatting, and in this you would say, you would change the, I'm typing change, I'm telling you to change your markers when you have multiple sets of data in the same set, so you use different markers. That way they're distinguishable. And you say change markers show run 1 is diamond, run 2 is, I don't know, square, and so on. And you fill that space out accordingly. And there's that. So now this figure caption is pretty well set to go. And we fixed the figure, we fixed a table. And what we can do is, since in this particular case, this student used 2 separate tables to present their data. So I'm going to leave it like that here, because otherwise I'm just fixing this and I don't want to fix it. I want to demonstrate to you what you want to make sure you're building in there. I'm going to move this heavy one over to the other side just to kind of get the order of thinking processes in the right order. Oh, look what that did. Let's make that bigger. And apparently the setup of this one is wrong, so I'm going to come up here to design, show you how to fix that problem should it come up for you. This is weird. So I'm going to undo what I just did. 1, 2, and let's figure out what we did wrong. This is probably in line with text, yep, and so the table is kind of acting funky. Now it's in line with move in line with text as a square shape. And kind of give it approximately the same dimensions that we gave the other one. You see what it did? Just popped right over to the other side. So they kind of have a built-in style to them. To move a table around, let's just move this. I'm going to just drag it down a little bit. Yes, I'm going to put it what appears to be inside analysis, but I'm just getting it out of the way. This is odd. Okay, so let's just kind of come up. We'll figure that out in a minute. All right, so let's see what we see here. So what they've started writing is, as described above, time and velocity data were collected, which was then used to find the average acceleration of each trial. Data from the lighter compiled a table, while the data from the heavier table 2. See next page. The percent error collected data from the accepted values is included in the section. Now you come down here and you can probably anticipate that they'll reference the scatter plots in the analysis section when they should be referencing them to highlight them and start it off in your oh, that's what it is. This guy is over here. A little trick for you: if you come up onto your home page and you can click on this, this will show and hide all the markers and markings and different editorial things that are going on in your page, so that you can fix whatever you need to fix. So it looks like we got some hard paragraph returns that are for section returns. So I'm just going to hit enter a few times. Okay, still reading it as that, so maybe I leave that alone, and we'll drag this on here. And this is what part of it is keep in mind, I'm fixing something that's in place. You're going to do stuff with more of an experienced touch because of the stuff that we did ahead of time. There we go. So I've just got some. These are regular paragraph breaks. You notice these are bigger. These are section break paragraph breaks. So that's what's causing some issues. So I got everything kind of moved out of the way, and now we can stretch our legs up here in the top. As described above, blah blah blah. The data from the lighter photo gate. Average acceleration. So this is not exactly correct. Oh, we can turn off the formatting now. I'm going to hit enter to break that up. The data from the lighter photo gate is compiled below. So let's go down here and grab the reference to the top. We produced scatter plots of the lighter velocity of time. Below the plot of the heavy photo gate is shown figure 2. Each trial, each function applied. This is all, so you see, analysis is for making a statement. And this is all set building. This is all world building for those of you who like the game, who like Minecraft or something like that. You got to build the world before you can go play and battle whatever, the creepers or something. So a linear trend line is expected for this is because okay, they were probably when the picket on the only force acting. This is more conversation, so there is a constant acceleration of the picket fence. Okay, so that's just kind of repeating. So that's kind of a redundant expression based off of what they should be putting up earlier in what they already did put up in the introduction. So they're just out of ideas of what to say. And the way to fix that is to do what we're doing here: is get your results section, get that house in order first. I'm going to go ahead and clean this up by making this all justified. And now I owe the NFL residuals and stuff, you know. Alright, so the data which were then used to find the average acceleration, I think this should not be average, but the experimental acceleration of each trial. We produced, to do this, you might even just change that to say to do this. We, lowercase, produced the scatter plots for the lighter and heavier photo gate trials of velocity. So they kind of got their sentence inverted. I think this is like splitting an infinitive or something like that. Scatter plots of velocity versus time for the lighter and heavier photo gate trials. Now, the next sentence is the plot of the lighter photo gate. That's the start of a new thought, the start of a new sentence. I mean, it's one sentence that we had, but it breaks it up and makes it a little bit more of a clean read. The plot for the lighter photo gate shown in figure 1. We don't need below because it's immediately there to the right. And you don't have to stick exactly to how I'm doing this. Get the sense of what I'm doing. Maybe it would be better to move this figure up to the top of the page, and I think that oftentimes is actually better. Maybe you stretch it out just a little bit more so that you have the caption to the left of it, and they kind of occupy the same space, and there's not a whole lot of white space left over. While the plot of the heavier photo gate is shown in figure 2 below, which, see next page, that's probably where it's going to end up, and that's fine. Each trial has 5 runs. A linear function, each trial had 5 runs. That's fine. We'll leave that there, and we'll start a new paragraph. A linear function, trend line, and you'll notice if we just kind of give this a little bit of a squeeze right here, not much, boom, we've eliminated a little bit of white space, and it still reads pretty nicely without being cluttered. The linear function trend line was applied to each of the 5 runs. A linear trend line is what was expected for each run, since acceleration due to gravity is a constant, and the slope of each function. And in this case, this is when you reference the original figure. You're justifying why you made begun the steps of analysis that you did. You applied a linear function because the relationship that is not labeled up there, figure 1. So I'll put in here first equation. And now you're calling back to you say, this is why I put it there, so we could talk about it now. Let's see here. This is because the derivative of the velocity versus time graph is acceleration. I'm going to delete that out of there because as far as you guys are concerned, if you've done calculus, it makes sense, but even then it's a little bit overkill. It's kind of like, and then I hit the hammer on the head with a sledgehammer, and it continued to stay hammered in. So the data from the LiDAR photo gate is compiled. So that's too generic. Let's see. The slope data from the LiDAR photo gate is compiled below in the table labeled table 1. That's redundant. And just call it. It's a proper name. Just call it table 1. Notice that they accidentally typed in there as an Arabic numeral. That should be capital I. While the data from the heavier photo gate is compiled in table 2, again, there you go with swinging back to what we're talking about. This data in your work will be compiled to the same table, so you can just refer to them as is heavier data 1. The percent error of the collected data from the accepted value of acceleration due to percent error of the collected data. Okay, it's a bit of an awkward sentencing. Maybe it makes more sense to you guys, and you're like, oh, what are you talking about, LRTs? This makes perfect sense. But as far as I'm concerned, I'm trying to fix the mat underneath my chair. See a numerical analysis section. So they already put that in there and said, look back in that original. So previously they had it, I think they had it lower is part of the analysis, so it was after the statement, but we've moved to the front. So now it's more naturally a reference because you're saying, see the numerical analysis section that you've already seen, not that you got to go find and look for. So so there's that. So, and all we've done is so far, look at how much has been written. All we've said is, here's what it is, here's what we did, here's why we did it. And this, we haven't done anything remarkable. We've just said, look at this. And you know, we've put together a pretty nice little bit of content. So you probably have like your figure 2 here. I'm not going to move anything right now because those anchors get messy. Put your content in place, then move all your objects around to make it look nice. That's really the best way to go. Let's see here. So here they say okay. So these calculations here, I wouldn't. This is overkill. This is not necessary. It was a nice effort by them, and maybe doing one would be a good demonstration to say this is what the calculation looks like. But again, it's a little bit of overkill. So you could just say G average is 9.721, but even then, now you're redundant. What they forgot to put in there is the averages value and their percent difference calculation. This would just go into the table. You don't need to demonstrate this. You say, here's what we got. They can see the numbers in the tables that you already have in place, and then you write that down. If they don't trust it, they can pull a calculator out and run the numbers themselves. You know, don't overkill. And again, you saw what we did. You know, I copied or I think I cut and pasted and pulled those up there. Now you've got equations 2 and 3 up here, and you see them again down here, and what they're trying to do is say, you know, this is how we put the stuff in place, but it's overkill. I'm not going to worry about deleting that. I just wanted to make the point. Here you got the calculated percent differences, and they're just making a statement. So there's not really a whole lot of analysis that's happening in this, nor was there a lot of stuff. So how else would you continue to build this up? You might say, let's see here. So one thing that you look at, say, okay, we've stated what we've done. We stated why we did it. We stated how we've accumulated this data for easier analysis. Namely, take the information that we are demonstrating in the plots and whittling it down. I was looking for shriveling, I guess. Whittling it down to just the slopes, because those are the values that most closely reflect acceleration due to gravity. And maybe at this point you say, okay, here's the table, and you notice that everything is lower than 9.8 meters per second squared. That's something that's worth remarking on. This person did not do the formatting here, but we're going to do that. So you highlight those numbers, come back to the home page, or is it elsewhere? Let me see here. Let's right click on that, and that doesn't do anything, so I'm going to close that out. And what I'm going to do is I'm just going to manually round this. What you probably would do is go ahead and get the formatting taken care of for like the number of decimal places done in Excel or Google Sheets, and then move it over so that you don't have to worry about dealing with this detail. That's 608, so that rounds up to 1. This is 0.3049, so that's going to stay 0.30, and 0.4262, that becomes 0.43. So now it's a little bit easier of a clean read, and you point out, you say, hey, look, 5 data points, they're all lower at least than the acceleration due to gravity. So that's the first thing that we say. Some details to consider in our collected data in the tables. Let's not say collected data, let's say collected slopes in the tables, is that they are all consistently lower than the given value for G. G is a variable, so we're going to italicize that. You don't need to keep replacing 9.8, 0665. You just make a remark. I'm going to go ahead and start deleting some of this so that we're not losing the reference stuff here. But if we look over here in this case, let's go and make this work. That's 0.98, 0.56. That becomes 0.57. This is 2.33. If you have any questions about significant figures on here versus significant figures as far as decimal places, I'm happy to have that chat, but this is more consistent with my understanding of how we should do this. Alright, so in this case, 9.7, 9.7, 9.5, 9.7, 9.6. Did you see what we came across there? 9.57. So if we look at that first table, which is now hiding behind this, I know what happened. This is, okay, let's just bring this to the top. Oi! This is why you do formatting after you do content, because it's a lot easier to find a place for it when you've got content in place. If you don't have content in place, now you got to deal with all this busyness. Alright, let's move this kind of over here. Just get that out of the way. So there's a couple other tricks that we could do if we really were looking for it that I can show you in case you're still running into formatting issues. Okay, so they're all consistently lower than the value for G. Of particular note, let's see here, 9.6, 9.6, and then, so that's 2, 9.6, that's 3, and then 9.5. So that's 1, 2, 3, 4 data points that are below 9.7. Oh, that should be our particular note. 4 of the slopes are, let's say, fall below. There's a little bit of wordplay there. 4 of the slopes fall below 9.7 meters per second squared. Specifically, let's put a semicolon there. Specifically, one of the drops for the heavy. It says photo gate in the graph, but it should be picket fence, so don't let that trick you. Picket fence is around or below 9.6 meters per second squared. Again, you're not saying anything of whether it's good, whether it's bad. You're just saying there they are. Be aware. We're going to talk about it in the next section. And that was supposed to be a semicolon. Okay. Anything else that stands out? Most of the data points do lie below, well below 5.0. Let's see here, percent error. I just noticed that. I didn't catch it. I don't know if anybody else has noticed it so far and wondered if I caught it. The answer is there's no R squared values. So we don't have anything on this case to say about what the R squared value is unless we went in here and actually manually add it. So let's go ahead and manually add it just for one, because you want to be able to comment on this. So let's format the trend line. The little tile pops up. We're going to display R squared on the table. And where did it go? Oh, it's hiding. Sometimes you got to turn these off before you can see it. So right click on the yellow ones. Remember that you want to change the shapes, because when it prints out in black and white, it can when it prints out in black and white, you can't distinguish them so easily. So now let's do that. And we're going to come in here, we're going to display equation R squared. There it is. R squared equals 1 for that guy. If we pop down here, that 9.5, I want to see that 9.5 slope. That's this gray one right here. You have to turn off the slope, the equation. Once you make an adjustment to the equation, you have to go out of it and then go back into it. So these are things that you just kind of pick up as time goes on. Why does it? Oh, I saw the yellow one and I thought about it from the previous one. Format trend line. Now it's back in here. Add table R squared. Look at that R squared. That R squared value is 0.9973. That's still good, and that's the important thing, is that the data is still good, but we're not in the analysis section yet. We can't declare that as good. We can only, right now, all we're doing is trying to identify that it is there and that it has some importance. The R squared values for all 10 slopes is close to 1, and then maybe you'll notice, okay, what is the R squared value for each of these? If you went back in and did this and you had all these R squared, does the R squared value for the one that's got the lowest slope and the furthest away from 9.8, is that one consistent? Does it have bad data in there, or is there another structural thing? If it's got a good fit, the data came through smoothly. Whatever it did smoothly. So there's another concept that you can put out there to consider. So hopefully this has done some good stuff, because now think about what you've got here. If we were to go into the analysis section, the next thing that you can say is, okay, we produce heavy plots, lighter photogate trials, plots shown here. And I mean, this is a stepping stone to the data tables that you build up, so there's not much to say there. But linear function trend line was applied for the 5 runs. The linear trend line is expected. Maybe in this case, you would be the R squared value for all the trend lines seem to suggest that the linear fit is the best fit. And then you go down towards, go to that other subsequent paragraph, and you talk specifically about the R squared. Maybe there's relationships between the R squared value and a given data point. And again, even though this is all really good data, and on, in a professional setting, you would get these values and you move on to deeper concepts. In this case, this is the stepping stone. This is us learning how to do this and be able to make that kind of analysis. So let me come down here and see if there's anything else. Okay, so in the analysis section, you would say the R squared values were inconsistent. The 9.5, 9.6 values, they still had good values. So now you have an opportunity to talk about why are those different than 9.7 values. And then you start thinking about, okay, what was the experimental setup? You had the laser beam, and you were breaking that laser beam with this picket fence that had these 5 centimeters. And what's going to change a speed measurement? Well, the speed measurement is only going to be changed if the distance changes or the time changes. Well, the time is measured, and the distance is prescribed. It's 5 centimeters. So what would make it higher? In this case, lower acceleration. Remember, it's velocity divided by time. And so if the time is accelerating in a consistent way, what's changing? How is the speed changing, or distance rather? How is the distance changing for the speed? Is it getting bigger, lower? So something to think about it in there, and as you get into the analysis, you can talk about the slope of the data from the library compiled below. So now you would look in there and you say, okay, if I took an average of these values, it still follows what the average is. Let's take a look down here at the bottom. For the lighter picket fence, 9.73. And so for the data table, 9.73 is higher than 2 of the data points and still lies in the 9.7s. And so, there's something to say about that as far as percent difference, percent error. Not percent difference in this case. Percent error. All the percent error is well below 5%, which suggests that the experiment did not show heavy influence from external contributors, and that each of the data points is well within statistical limits to be accepted as viable percent error. Now you're in the analysis section. Now you can make opinions about it, but you're not just saying it worked out nice. You're saying because the percent errors are below 5%, they're viable. Were there factors? There's clear evidence that there's factors at play that were contributing to our data being good or bad, especially at 9.5 and several 3 and 9.6 values for the acceleration. And if you can work out what that contributing factor is, there's your hint, then you have something that you can talk about a little bit more. Again, we put a lot of information in here, and all we just did was say, look at that, look at that. Now you have something that you can say, remember that we talked about? Let's talk about the viability of that. That's the basic, that's really it. That's what this whole exercise is about, is just kind of being able to go in there and fill in that results section a little bit better so that you're setting yourself up for more robust conversation about what the analysis of your data is going to come to. Remember that you also have in this particular lab, you had that mass measurement. So you can even point to your second data table, that has the masses, and you can just comment they're very large compared to the average values for those, and that appears to be something that's going to be a major factor in the next section. Then you get to analysis, and you actually talk about, and then you talk about it. All right. Hopefully this is giving you some insight into how to work through the data points and how to think about what to say. It's a starting point for sure. Each lab has got its own little quirks and characteristics, but at the end of the day, it comes down to, okay, what did we do, why do we do it, and what do we make of what we've got? And before you can say, what can we make of what we got, you guys say, here's what we got, and here's some things that stand out about it as me, an analyst of this data. So any questions, always reach out, send an email, and thanks for listening. I hope that you found this helpful.